We're talking about the maximum times a graph could turn, and we just talked about how this is an x to the fourth polynomial, and it turns 1, 2, 3 times, and it couldn't turn any more than that, because then I'd have a fifth solution, and I already have 4, and that's the max I could have. If I look here, I already have 1, 2, 3 solutions. This is an x to the third. I can't have any more. How many times does this thing turn? Twice. 1, 2. Are we noticing a relationship between the degree and the maximum number of turns? What is it? The degree here is 3, and the maximum number of turns is 2. The degree here was 4, and the maximum number of turns was 3. So, the maximum number, go ahead. It's 1 less. Let's see if that holds true for a quadratic. Here, I already have my 2 solutions. How many times does it turn? Once. How many times does this thing turn? None. So yes, the maximum number of turns is just 1 less than the degree. That's it. So that's an easy answer. If you, whoa, where's my paper? Here it is. So the answer to number 1 is just 1 less than the degree. That's it. So the maximum number of times this thing could turn around is 4. It doesn't matter if your Lie coefficient's positive, negative. It's always just 1 less than the degree of the whole thing. Does that make sense? Okay. So you could go around and answer number 1 for all these super fast. You might as well do that. Just so we have it all complete. We don't have to worry about doing it later. Always just 1 less than your degree.
What is the answer to 7 and 9? For like the infinity? What if there was
Right, it doesn't turn at all, because it's just a straight line, right? And it'll just, yeah, it'll never turn. And again, that's the maximum. It's not saying it has to turn that many times. It's just that's how many it could turn. Can't have any more than that. All right, the next thing they're asking us about, you already know how to do number 2. Determine the real zeros and state the multiplicity of any repeated zeros. That's just what you've been doing. Find the zeros of these things and tell me if any of them have a repeat or not. So let's start with one that's not so bad. Let's start with 3. So if I'm going to find the zeros of this thing,
3 answers.
I'm going to have 3 total answers, right? Oops. What would I do first? What would you do first? I would factor out an x squared, and I'd be left with x plus 2. So what are my 3 answers? I get 0 2 times, so I get 0 with a multiplicity of 2, and I also get -2. There's my 3 answers. 1, 2, 3. That's what they're asking for in number 2. Now, so number 2 is right there. Sorry, I kind of made a mess of this whole paper, but whatever. Now, number 3 is interesting because here's what they're asking for in number 3. They're asking you from that list that you just found, where is it going to cross the axis and where is it not going to cross the x-axis? All right, so in order to determine this, I want to show you a couple of things. Let's see if I can, I'm going to hope on my graphing calculator I can get some nice graphs here. Let's say I had a quadratic that was x plus 1, x minus 2, and maybe an x, oh, I don't know. How about just x? Yeah. So if I were to multiply that all together, what degree would my polynomial be? X to the third, right? I have, because I'd FOIL those two together, and I'd have x squared times another x. So I'd be x to the third if I actually multiplied it all together, right? I have this thing in factored form right now. I know that it's going to cross the x-axis at 3 places. Once at -1, once at +2, and once at 0.
Wait, how did you do that?
I just made it up. But if I multiply it all together, I'd have some x to the third plus minus blah, 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 blah. Whatever it is. Okay? So, I know it's an x to the third graph. My leading coefficient's positive, right? If I FOILed all that together, it would be positive. So I know the ends are going to do this, right? The left is going to go down, the right's going to go up. And because it's in factored form, I know it's crossing the x-axis, okay? So let's watch when we graph this. Yep, there it is, okay. It does everything that we expected it to do. It's coming up from the bottom, it's going to go up to the top, and it's crossing the x-axis exactly at the places that we said. So, I have 3 solutions, and at all 3 of these x-intercepts, the graph is crossing the x-axis. It's going from, here it's going from below, it crosses it and goes above. Here it's crossing and it comes back down, and it crosses it again. What happens when you have a double root? How does that change the graph? Let's see. Let's say I had x plus 1 twice. So this is going to cross the x-axis at -1 as a double root, and then again at 0. I should probably spread it out a little bit. Let's make it x plus 4. So I have 2 x plus 4s and an x, just so I have a little bit of space between the two. So I get -4 as a double root, and then 0 as my third root. Everybody agree? The end behavior should still be the same, but let's see what happens with a double root. How interesting! So look at -4. -4, it was a double root, but it's not crossing the x-axis, it's just going to touch it. What if I had -4 as a triple root? What would happen? Well, let's find out. Let's add another x plus 4 in there. What the hey? So now I have something to the, if I leave that x in there, which I will, now I have something to the 4th power, right? Right? But I have -4 as a triple root. What do you think is going to happen? Is it going to cross the x-axis? Is it going to touch it and bounce off? What will happen? There's only one way. How interesting. So, it crossed through. It does cross at 0 also. It's just really hard to see because it's really steep right there. But, so it's crossing at 0 and it's crossing at -4. What if I had -4 as a quadruple root? Gotta find out. And I'll leave that x in there still. So now I have an x to the 5th graph. Let's see. How interesting. It didn't cross there. It just touches it. So, are you noticing a pattern? Yes. If you have, so if I have an answer, let's do this. If I find my x-intercepts and it's 1, 5, and 3, or whatever, who cares? Each of them only appears one time. It's going to cross the x-axis at each one. Cross completely, not just touch and bounce off of it. It's going to cross. If I had this, 1 with a multiplicity of 2, 5, and 3, what's going to happen here is that this, it's going to just touch at 1. It will cross at 5 and 3. But if I have a double root, it's just going to touch right there. It's not going to cross through.
What would you do if, like, 3 was the double root, because it's, like, in the middle of them?
Oh, you could have that, sure. So then it would just look like, your graph would look something like this. Like that. Oh, sorry. Oh, if you had 4 roots though, then this will come back down. Would look like that. So your middle thing's just touching. Okay, so if I had this, let's say I had 1 with a multiplicity of 3, and then the other point's 5 and 3. If the multiplicity is odd, it's going to pass through just like the others. So any odd multiplicity passes right through. Any even multiplicity bounces off the x-axis and won't actually pass through. It'll just touch it there and come back. Does that make sense? Okay, all right, all right, all right. So that's going to be really useful when I'm trying to graph this by hand to know what's happening at each of these zeros. Okay, so that's what they want you to explain in number 3. So number 3 says list the x-intercepts where the graph crosses the x-axis and those where it does not. So at 0, what's it going to do? We had a multiplicity of 2. Yeah, it bounces. So at 0, we can say bounce or doesn't pass or whatever you want to say. So at 0, it bounces, and at -2, what happens? Yeah, at -2, we're going to cross. So basically, it boils down to if you have an even multiplicity, it's going to bounce. If it's an odd multiplicity, it's going to pass. So a single answer, right, just listing the 5 and 3 one time, that's an odd multiplicity, so they're passing right through at those points. And since this just so happens to be odd, it's passing through right there also. Okay, so let's try one like 4. We already know that the maximum number of turns is 1. We already said that. And number 2, we have to find those. We have to find the x-intercepts. So what might you do with this thing? X squared plus 4x plus 4. You can if you want to do more work than you have to. Yeah, just factor. Factors of 4 that have to be 4, 2 and 2, right? So isn't that just x plus 2 times x plus 2? So what does that mean? My answers are -2 with a multiplicity of 2. So at -2, is it going to bounce or is it going to pass? Bounce. So at -2, we're going to bounce. Does that make sense? Let's jump down to, I was thinking 8. All right, so if I'm looking at 8, first of all, what can I do to this thing? I can take out an x. In fact, you know what? I'm going to take out a -x because I don't like that my leading coefficient's negative. So I'll take out a -x and I'll leave it with, excuse me, positive x to the 4th minus 2x to the 3rd plus 2x squared minus x. Oh, just kidding around, seeing if you're paying attention. Yes. Okay, there we go. That's better. And now I'm going to go ahead and factor by grouping because I think that will work. So I can take out an x to the 3rd, x minus 2. Oh, shoot. Oh, man. Doesn't work. That does. Wah, wah, wah. Dang it. Well, I have one of my 5 answers. What is it? 0. Great. Now I have this. But, oh, look at my n numbers are just, my factors are either +1 or -1. So when I go to do synthetic, it should be really easy. 1, negative 2. Don't forget, I don't have an x squared, so I need a 0. 2, negative 1. Let's see. 1 or negative 1 hopefully will work. Negative 1, negative 1, negative 1, 1. Nope, negative 1. 1, 1, 0. Hooray! So one of my other answers, so one of my answers was 0. Now I got positive 1. That's my remainder, constant, x to the first, x squared, x to the third. So now I'm dealing with, I need to write this bigger on the other sheet. X to the third minus x squared minus x plus 1. Can I factor this by grouping? I hope so. Take out x squared, x minus 1. Take out negative x, x minus 1. Hey, all right, I got it. So x minus 1 and x squared minus 1, which really factors into x minus 1, and that one's going to split. So I get, I get positive 1 2 more times, and I already had it once. So I get positive 1 with a multiplicity of 3, and I get negative 1 one time. I'm supposed to have 5 answers. Before you continue, make sure you have 5. I have 0, I have negative 1, and then I have positive 1 3 times. 1, 2, 3. Is this graph going to bounce anywhere? No, it passes through at all of them. Remember, if it's an odd multiplicity, it passes right through. So it's going to pass through at 0, at 1, and at negative 1. So 3, we can just say, I don't know, pass through all. Pass through everywhere. Does that make sense?
Wait, when they bounce, was it 0 or 1? Did you get 1 twice?
I got 1 3 times. Yeah, I got positive 1 as 3 of my answers. So since it's odd, it's going to pass through. And I got 0 one time. That's odd, so it's going to pass through. And I got negative 1 one time. All right. What do you think? Okay-ish?
I lost one of the ones.
I had the very, so you had the 0 from the beginning. You factored out an x, right?
I forgot that one.
Yeah, so that 0 works, and then the very first one I plugged in, that worked. Got me down to my cubic function. All right, so I think we're ready for our homework.